When it comes to engineering and development of cars, many people think that Elon Musk is the genius of our generation. I feel a little different, however. This is Christian von Koenisegg, and this guy does the impossible. From his fully automatic and manual transmission to his insane hypercars, this man knows how to build amazing cars. Now today we will take a deep dive on yet another insane thing this man and his company has built. This is the Koenigsegg Gemera, and it's a hybrid 4-seater hypercar. Now the electric engines make 1100 horsepower, but that's not the part I want to focus on. As it's a hybrid, it also features an internal combustion engine, specifically a little 3-cylinder 2-liter twin turbocharged engine. This 2-liter twin turbocharged 3-cylinder power plant delivers an astonishing 600 horsepower, setting new standards in specific output for road cars. Now this engine is nicknamed the Tiny Friendly Giant, or TFG. Now what makes the TFG even more fascinating is its camless design, employing cutting-edge technology from Koenigsegg's sister company, Freevalve. Let's delve into the engineering and technology behind this remarkable engine and explore how Koenigsegg used this Freevalve technology as well as its genius sequential turbo design to make 600 horsepower out of a 2-liter power plant. First, let's start by explaining why he chose a 2-liter for his hypercar. You see, the TFG was specifically designed for the Gemera, aiming for a compact, lightweight engine with substantial horsepower. Koenigsegg, known for its innovative approach, chose to reverse the power distribution seen in the hybrid Regera, where the internal combustion engine plays the primary role. In the Gemera, most of the power is generated by the electric motors, with the TFG contributing propulsion and serving as a charging unit for the hybrid drivetrain's batteries. To fulfill these requirements, Koenigsegg opted for a 2-liter 3-cylinder configuration, maximizing power-to-weight ratio while ensuring ample space within the vehicle. Remember, this is a 4-seater hypercar. Despite being a 3-cylinder engine, however, the TFG packs a punch. This engine features a bore of 95mm and a stroke of 93.5mm. The TFG exhibits a big bore, big stroke design that delivers a distinctive and powerful exhaust note, reminiscent of a Harley, with an additional cylinder. Just take a listen. The engine's exceptional valve engineering allows for high revs, with peak power achieved at 7,500 rpm and a redline set at 8,500 rpm. Remarkably, however, this engine delivers more than just high-end power. The TFG also generates substantial torque, delivering 600 Nm below 3,000 rpm, and it keeps this high torque all the way up to 7,000 rpm, ensuring an impressive mid-range. Now, how do they make all of this power? Well, one of the TFG's ingenious features is its sequential turbocharging setup. Each cylinder is equipped with 2 exhaust valves, with one dedicated to the small turbo and the other one dedicated to the larger turbo. At lower revs, only the small turbo exhaust valve opens, providing rapid boost response. As the engine surpasses 3000 rpm, the big turbo exhaust valve opens up and it starts to generate substantial boost, which increases power and torque. This sequential turbocharging arrangement optimizes performance throughout the rev range and contributes to the TFG's impressive power output. But that's just one part of the equation. The other big part is the fact that this engine has no camshafts, which are replaced by a Freevalve technology developed by Koenigsegg's sister company, Freevalve. Now, instead of cams, this engine employs pneumatic actuators to independently control opening and closing of each valve. This level of freedom enables precise control over valve lift, timing, and duration. At low loads, only one of the 2 intake valves per cylinder opens, ensuring efficient fuel distribution. The constant fine-tuning of intake valve lift and duration eliminates the need for a conventional throttle and allows for individual cylinder shutdown when necessary. Freevalve also facilitates seamless switching between the traditional autocycle and Miller cycle, wherein intake valves remain open longer to minimize pumping losses, thereby enhancing power and efficiency. Now, I will say, as someone who works on cars as well, vacuum systems tend to fail. So I do wonder how they will ensure that this system keeps working reliably. Imagine getting a leak in a line and valves not opening or closing when they are supposed to. But I will say this guy is pretty smart, so I'm sure they thought of that. Anyways, let's get back to the engine and some of its other cool features. The TFG's revolutionary design allows it to potentially run in a two-stroke mode, and I say potentially because this has not yet been tested. But in this mode, as I said, the TFG would be able to operate in a two-stroke mode up to 3000 RPM. Beyond 3000 RPM, the TFG will then seamlessly switch back to four-stroke operation due to limited time available for gas exchange at higher engine speeds. Furthermore, Koenigsegg is collaborating with Spark, Cognition, an AI company based in Texas to develop advanced engine management software for the Freevalve engines like the TFG. This AI-driven system will learn over time to optimize valve operations for fuel efficiency and emission reduction, potentially uncovering novel combustion strategies beyond human understanding. While this technology remains in its early stages, it highlights Koenigsegg's commitment to pioneering advancements in engine development and keeping the internal combustion engine alive. To further prove this point, the TFG is a flexible fuel engine designed to burn various alcohol-based fuels such as ethanol, butanol, or methanol, either individually or in combination. The use of alcohol fuels not only enhance performance but also contribute to the engine's cleanness by generating fewer harmful particles compared to gasoline. Now, when powered by sustainably sourced fuels, the TFG can achieve carbon neutrality, aligning with Koenigssegg's commitment to environmentally conscious engineering, and they are going further than just developing engines that can run on these good fuels. Koenigsegg is also investing in a thing called volcanol, which is basically a methanol-based fuel produced by using active volcanoes. I made a full video on this, and if you would want to see it, I'll leave a pop-up and then you can go and watch it after this video, or you can watch it now. It's your choice. But back to the video. What does all of this technology cost? Well, while the Freevalve system used in the TFG is more expensive than the conventional camshaft setups, it compensates for this by utilizing fewer raw materials, reducing overall engine weight. Koenigsegg estimates that the TFG engine manufacturing costs are approximately half of that of their 5-liter twin-turbo V8 engines. But it is also a much smaller engine, so I think like if they made it the same size, it would probably be a bit more expensive still. Conclusion: the tiny friendly giant engine developed by Koenigsegg represents a paradigm shift in internal combustion engine technology. With its exceptional power output, compact design, camless operation, and advanced features such as sequential turbocharging, combined with the Freevalve technology, the TFG engine redefines what is possible with a 2-liter 3-cylinder engine. Now, the Gemera was revealed in 2020 and it has been 3 years since. So it's been a while. But it does have an estimated delivery date of 2024, and it is a completely new technology that has to be thoroughly tested. You don't want to get the car and then it's like, this is crap, it doesn't work. Let them test it properly. I mean, nobody bats an eye when Tesla announced the Roadster in 2017, and we are still waiting, and that thing just keeps getting postponed. These things take time. Anyways, if you guys enjoyed this video, please leave a like and subscribe to the channel. And if you did like it, you'll most likely like all of my other stuff. So just go through my channel, see if there's something else you like. I'll check you guys in the next one. Cheers, eh?